How can I be lost if I've got nowhere to go? This is a walkthrough for solving Mostly Harmless, Hyperspace Bypass by Aaron H. If you'd like to tackle the puzzle yourself first, please see the link in the description. Okay, so what I will do is, as we encounter rules, I will cover them off as we go. Just find it's a bit easier to keep it fresh in the mind because there's a few different rule types that we'll come across as we go through this puzzle. So to start off with, this is a dynamic fog puzzle. So the grid's covered with fog. Entering correct digits may clear fog from elsewhere, but no guessing is required. Any lines that you see and markings do continue and connect beneath the fog, but unless otherwise revealed, no additional clues should be assumed to exist under the fog. And the constraint on this puzzle is disjoint groups, which means that a digit may not appear in the same position in more than one 3x3 box. So just to give that a bit of a description, if this cell was a 3, it would mean that none of these other cells here could contain a 3. And similarly, if it was this one, like if they're in the same position within the 3x3 box, rules it out of all these other ones. So yeah, that's sort of the base to get started. So first line that we can see here is a 10 line. It's a grey line that's divided into contiguous segments. The digits in each segment sum to 10. Segments do not overlap and their boundaries are not indicated, so solvers must determine them. So firstly, I will shade in the line just so that we can visualize it a bit better. What we can sort of say about this line is, because it's got 8 cells within a box, we know that there's sort of 4 pairs of digits that will sum to 10. We don't know if it sort of starts here and continues, or starts here and continues, but it will do one of those sort of things once we work it out. It'll just be something we have to work out along the way. But one thing that we can say for certain is 5 does not appear on the line, so it goes in the center cell. That then brings up a green German whispers line, which adjacent digits differ by at least 5. So because this is a 8-cell line within the box, we can sort of begin to work out how things need to go. So there's 2 digits which only have one partner, so they must be at the end of the line, and then their partners must be next along the line. We just don't know where it's starting from, so and then everything is kind of forced because these digits here only have 2 numbers that they pair with, and one of them is this one, and then these are the final ones that go in the middle. So yeah, that's the basic structure for our German whispers line at this length. Once again, 5 does not appear because there's no digit that's sufficiently different from 5 in Sudoku. So that opens up more of the grid. So what we see next here is a teal line, which is a modular line, and the rule for this is that any 3 adjacent digits along the line must include 1 digit from each of the modulo 3 sets. So modulo 3 is a maths operation. When you divide by 3, it's just saying group the digits according to the remainder left over. So in the case of Sudoku, you get groups of 1, 4 and 7, 2, 5 and 8, and 3, 6 and 9. What's helpful with these lines is to often mark them up with colours, because you know there's 3 different sets, you just don't know which set is which, but you know these are 3 different ones. Because it's any 3, you then know that this colouring continues along, and you can just keep this pattern going until you reach the end of the line. So off the bat, can look here, and because 2 and 8 and there's a 2-8 pair here are one of the sets, we can sort of very quickly say that this red set is not the 2-5-8 set, because there's not another 2 digits to go in from that set that could fit here, because there would be a clash here trying to select from 3 different digits, and there's 4 cells. So it's not actually much more that you can determine. These other pairs, they aren't sort of within the same group, so you can't play that same sort of trick. So I'm going to come up here and look at this yellow line. So yeah, as we can see, this one is going through and connecting under the fog, forming an X. And with a yellow NABNA line, the line cannot contain 2 digits anywhere on that line that are consecutive. So that because this one is 5 cells long, we know that that is all the odd digits from Sudoku. So we can look at this cell and know that it's odd. But down here we can actually rule out 1 and 9 from it, which leaves us with 3, 5 and 7. But because of the disjoint rule as well, we also know it can't be a 5 because it's already been utilised in the centre here, so that actually makes this only 3 and 7. Now with all of these cells down here, we can actually start looking at them in mind with the modular stuff, because 1 and 7 have been consumed, as well as 3 and 9. And for this blue set, that means that it can't be either of those sets, and must be the 2-5-8 set in here. And if we look along here, we can see 5's ruled out of this cell from Sudoku. 5's also ruled out by this disjoint groups rule, so that's the only spot there for a 5. And we get some more parts of the grid opened up. So this up here is called a killer cage. Digits within a cage must sum to the number shown in the top corner. And what we can sort of easily do here is, we know a box of Sudoku sums to the secret, 45. Subtract 42 means that 3 must be the sum of the digits here, and that is only done in one way. So that's what we can do in that box at the moment. But if we come back here to the purple zipper line, with this line the rule is that pairs of digits equidistant from each end sum to the same sum, and the center is marked by a dot, and because it's not within a cell, it's on the border of a cell, it's just the sum. It's not actually, if the dot was in the center, it'd be actually summing to what is in that cell. So because this is utilizing 8 digits, we can work out that it's either going to sum to 9, 10 or 11, because there's 4 pairs along this line, so it's either going to like the numbers that are divisible by 4 is 44, 40 and 36, so that's how you get your 9, 10 or 11. It means this center digit though is the one left out will be either 1, 5 or 9. Because of the disjoint set, it's not going to be 5, so we know this is a 1 or a 9, and that actually gives us a disjoint set 1-9 pair. So we know these are 2 different digits, and we know this can't be a 1, because then you wouldn't be able to put a 1 in either of these cells, so this must be the 2, and that makes this the 1. This actually can see this cell, so makes that an 8, and this one the 2. If we come back down here to the 10 line, we can look along the bottom here. Now, either here or here, one of these must be a pair that adds to 10. Like it's the only way the shapes could go. So, because there must be a pair somewhere in this set of 3, we can start thinking about what it might be. And if we look up here, we can quickly rule out that there can't be a pair here that adds to, can't be 4 and 6 to add to 10, because it would remove all possibilities from filling this cell. Can't be 1 and 9 or 3 and 7 for the same reasons. So there must be a 2-8 pair here somewhere. Now, this cell can't be a 2 from above. This cell can't be a 2 from the disjoint set, so the 2 can only be placed here. And then because the pair was somewhere along here, we know that cell is then the 8. What I will now do is just mark this up with X's. It's another way to indicate 10 pairs. So we know the cells joined by the X are the ones that add to 10, just make it a bit easier as we look forward. So what we've got next here, firstly what I'll do is mark up these centers, because we actually know quite a bit about the sort of center disjoint group now. So the only remaining digits that we've got left to place are 3, 7, 4, 6. So what we'll do firstly is come down here and look at this line. So this line here is an index line, so along a cyan line beginning at the square tip. The position of each digit determines another digit's location. So if a digit X appears, A appears here, then in the 8th position, so if this was the 8th position, this would then be the B. So probably a bad example, but there you have it. So each digit along the line must satisfy the position. So got something here to work with. This is the 8th position. That means that an 8 must be placed in one of these locations. So this is 3, 4, 6 and 7. So one of those must be an 8. But this 8 here actually rules it out of the 3 and 4 position. So that means this cannot be either 3 or 4. So that sort of starts whittling some stuff down. There isn't much here to whittle down these any further, but we can actually move on to the next rule. This here is a counting circle, so a digit inside a circle indicates how many times that digit appears amongst all circled cells. Now we've still got some fog here, so we can't say for certain how many circles are still remaining in these sets, but we can sort of calculate the maximum number. So what we can see is that we've got at least one circle here. There could be a second circle with the same digit as what's in here in this fog, and similarly there could be another circle within the grey cells somewhere with the same number. So at most there could be 3 circled cells in this puzzle at this stage. So this could be a 1, 2 or 3, just looking at that logic. But we can see from this 2, it can't be 2, so that rules that out. If it was a 3, it would actually knock out 3 from those locations. There's no 3s anywhere else there. So just would mean that there were two circled threes under this fog, which is breaking the rules of Sudoku, of course. So that means that circle can only be a 1. So what we've got here now is an arrow. The values of digits along an arrow must sum to the number in the corresponding pill. 2 cell pills are read from left to right. So what that means is these digits here sum to a number that you just read from this. So these aren't summed together, they're just read. So firstly, we can wipe out 6 and 7. That is way too big. A box only adds to 45. We can quickly look, if this was a 4, the lowest this could be would be a 1. That would subtract 5 out of the total here, so you'd end up with 40. 40 is less than 41, so it can't be a 4, it can only be a 3. If we then crunch the numbers around, it's pretty easy to determine that the only number that you can place here with the rest of the cells is a 6, because 45 subtract 9 equals 36, so these add to 9, and yeah, those add to 36, so it's a way to read it out. Okay, so now from here we can actually start to knock out the rest of the puzzle. So we can start resolving some things from the disjoint groups around the grid. It actually comes in here and sorts out the German whisper completely. So that's all done. That's now starting to resolve some of this. That's now 1. Okay, so firstly, what we can do down here is the remaining digits are 1, 3, and 7. Now, this here, the 1 must be in one of these cells, because this couldn't be 3 and 7, it adds to 10 and needs to be in a paired relationship. This can't be the 1, so that has to be the 1. That makes this a 9 to add to 10. This is a 3-7 pair. This 3 makes this one the 7 and this one the 3. 4-6 pair is the only thing that remains, so that's the 6, that's the 4 from this 6 up here. That gives us the 7 here. It's in the second position, so that must be a 2. This here is a 1-9 pair. The 1 rules it out here, so 1 is in the first position, 9 is in the 9th position. This is 3, 4, and 5 down the bottom here, and that's currently unresolved. So what we can move along to next is have a look around the Nabna here. So we do have some, because the ones on the line are all odd, these squares here will be all even. This one here sees 2 and 4 and 8, so that can only be a 6, then that can only be the 8. This is a 2-4 pair. So what we can move on to next is this one here can only be a 6, so that makes the green set the 3, 6, 9 set. This can't be the 3, so it's 9. That's where the 3 is. We've then got 1, 4, and 7 here, so that can't be 1 or 7, so it's 4. And this one can't be 7, so it's 1, and this one must be the 1. Sorry, the 7. Misspoke. Okay, so let's come along here to the zipper line. So yeah, if we have a look at the 3s, there's no 3s along that side of the zipper, so they're going down this side of the zipper, which means we're looking for an 8 in one of these positions. This 8 rules out these two cells, so 8 can only go here, which makes that the 3. Then if we look at 2, 2 is ruled out of all of those cells, so it just leaves it in one of these. Partners with a 9, 9 can't be in this cell, so this is the 9, that is the 2. 6 has only one position, that partners with a 5, we're totaling to 11. This can't be a 4, so that's a 4, and partners with a 7. Okay, so here we can finalize this index line. So 3 is in the 4th position, so 4 is in the 3rd position, and 5 is in the 5th position. Okay, digits left up here at 5 and 9 on this side, so this must be the 5, and this must be the 9. This 5 resolved that. This one here is 1 and 3, here's the 1, so that must be 3, and that's 1. Okay, this here should be completely gettable, and it's a 5. These digits are 7, 8, and 9, and I'll just mark it up and do. So that's the 8, that's the 7, and that's the 9. This is 1, 2, and 4. Also totally gettable. That bounces back up into here and fixes up those. Neither of those can be 3, so that is the 3. This must be 5 and 9, so that is the 5, and that is the 9. Okay, and let's start being, so we've got 1, so looking at 2s, 2s can't be up here, that can't be a 2, that can't be a 2, so that's the 2. 3 can't be along there, and that's a 3, so that's the 3. 4, 4 can't be there or there, so that's the 4. 5, not that, so there. And 6s, what do we have? Okay, that's a 6, so then that is the 6. Then 7s, that is a 7, that's not a 7, that's not a 7, so that's a 7. That is an 8, that is an 8, and that is a 9. And there we go, that is the walkthrough for Mostly Harmless, Hyperspace Bypass. I hope you found something useful in that. And yeah, feel free to make any comments or anything you like. Cheers.